Maybe we'll kick off. So, Cornelia, it looks like we've got a good audience in. So if you're ready, I'll go ahead with the introductions, if that's okay with you.
Yeah, that's fine. Yeah.
Okay, good morning, folks. So welcome to our second seminar in this semester's IS seminar series. So I'm delighted to introduce Cornelia Connolly. As many of you probably know Cornelia. So Cornelia is a senior lecturer over in the School of Education. She also has a background in computer engineering in terms of her research and also in her practice. And she's also a funded research investigator with LERO. So Cornelia has kindly agreed to give us a talk today on robots, teachers and tech, the learning sciences and computing education explored. So Cornelia, you're very welcome. We're delighted to have you as part of our seminar series. So I think Cornelia is happy to take any questions as we go along. The way we normally work, Cornelia, we kind of talk for whatever, up to an hour or something like that, and then we can have questions and answers at the end of it. But I guess if people want to interject and have a question or a comment, that's okay too, if that's okay with you.
Yeah, that's perfect. Thanks, Owen. Yeah,
thanks.
Okay, I'll kick off. And so thanks very much, Owen, for that introduction. And thank you to Professor Kieran Conboy also for the invitation to talk at the seminar. It's lovely actually to meet people from different disciplines and across the university community, isn't it? So yeah, so hopefully it'll be interesting for you all. So thanks for coming this morning. So as Owen said, the title of my talk is Robots, Teachers and Tech, the Learning Sciences and Computing Education Explored. So I hope, I was trying to think of a catchy title. Now I hope I deliver on this as well, but so we'll go with the flow anyhow. But I hope to present, I suppose, around some of the current trends and concerns in regards to AI and computing education, that's affecting education more generally. So now let's flow. Yeah, so we're just emerging from COVID, and there's no doubt that education and educators' roles have kind of changed, I suppose, and that relationship is intertwined with technology in the classroom, in the lecture theatre. And, often there's, I suppose, tensions around our pedagogical practices, the technology adoption and deployment. And I'm certainly not advocating that teachers or lecturers are going to be replaced by robots or anything like that. What we're concerned with, or what we want to explore, is really about teacher empowerment and educator empowerment. There definitely was a narrative, I suppose, in terms of AI and robots and educational technology about educational disruption, but yeah, this talk is not about teachers being replaced by robots. But just in terms of context and policy, just to set the scene, we have the EU Digital Education Action Plan that really looks at digital competencies in education. The education training framework then that the EU published was more concerned with lifelong learning, and that also from formal, informal, non-formal, and from the child right through to adulthood. Innovating education, education for innovation, then from the OECD, looked at the role of digital skills. And then within Ireland, we have our digital strategy for schools, and the DES action plan, our digital learning framework, all kind of set the scene in terms of digital education, educational technology, and within that, computing education. Yeah, as Owen introduced, I'm a computer engineer now lecturing in the School of Education here at NUI Galway. My master's was in telecoms and wireless networking. I did it through research a long time ago, and I looked at queuing theory on 802.11 when it was just emerging, so that kind of dates me, I guess. But I then worked in Accenture in IT and management consulting, and then returned to academia and lectured in computer systems, software engineering, during which time I undertook my PhD in pedagogical innovation in regards to computing students. After that, I actually, just when I finished the PhD, or rolling out from the work that we did on the PhD, I co-founded a Enterprise Ireland HPSU company, a spin out from UL, which really was technological infrastructure that underpins the Springboard Courses portal that some of you may be familiar with. But my current research is funded by Horizon 2020, Rethink Ireland, SFI, Google, and Microsoft. And so so national, international, and corporate funding, which is, I suppose, quite unique within the discipline of education. And I noticed some of my collaborators here attending today, so thank you. And that's the thing, I think, as well, isn't it, on all our journeys, you know, the role models and people that influence us, you know, we don't get to where we are alone. So I really want to say thank you to everyone that I work with and who works with me. But the learning intention of my talk today is really, like every lesson, we always encourage our student teachers to have learning intention set from the start. It's to reflect upon educational technology, computing education, and the learning sciences through a critical but positive lens. And there's a really interesting ontological tension about the models of education that circulate within computer science and the code it uses, or computer science educators, and the models of education that teacher educators and educational professionals hold dear. And I suppose I'm in the unique position that I can put both hats on. And so hopefully I'll you know, pose some questions, but also introduce some of the research that we're doing in this space. So yeah, I think to kind of set the scene, it's always interesting looking back and seeing how we've evolved and where we are now. So, you know, obviously from STEAM to electric to computing to the current big data and AI kind of era. And you know, there's been so much rapid change, hasn't there, you know, in terms of digitization, globalization, demographic shifts, geopolitical issues, and that all plays a role in terms of the context of higher education and then digital education and computing education. And if we look at this slide is from a paper by Gilly Salmon, and may the fourth be with you. So for any Star Wars fans, but if we actually look, you know, think about the industrial revolutions and how they've evolved, but also in line with that, the emergence of the web and the internet and how that has played a role in changing the dynamics and changing the face maybe of higher education, which in turn has a role to play in post-primary and primary education. So like higher education, our first universities, Bologna, Paris, etc., everyone traveled to the city. It was, you know, and really higher education was available to a tiny proportion of the population, but it was very much a transmissive form of education and a transmissive way of learning. When, you know, even our universities, or our university, when it was established, again, it was still very much a one way and for a tiny proportion of the population. But as the web kind of came into being, and maybe even Open University was set up and established, you know, there was more of a student-centered view of learning, and, you know, virtual learning environments started to emerge. Web 2.0 was more the social kind of space. We had websites, wikis, even MOOCs as they, you know, so then there was more interaction, and even I suppose blended learning started to emerge around that time. Web 3.0, we digital, mobile, and even at this stage, kind of university and higher education started to look more at employability and even recruitment and the delivery of learning. And then now we come to Web 4.0 and higher education 4.0, even, you know, where there's a student-centeredness, the experience of higher education is important, employment skills, employability, and that's all mixed with that's, you know, the symbiotic web of the AI and human intelligence being intertwined. And what Gilly Salmon talks about in Education 4.0, she really talks about that, you know, our disciplinary silos have to kind of kind of like disintegrate in some ways, you know, that really our new learning environments are broader, and that's been changed by AI, so to speak. In some regards, we've kind of entered an era of cyber learning. NSF, the National Science Foundation in the US, they define cyber learning as the learning that's mediated by networked computing and communications technology. It's really the degree in which technology is influencing education, as well as the way technology and education are intertwined. And then that combined with what we've all experienced in the last number of years with COVID and the pandemic, and how our teaching suddenly had to pivot to online. It's interesting, you know, that really technology becomes an essential infrastructure in shaping our learning spaces, but also our educational institutions and, you know, future generations, society to come, and how we learn. I'm gonna, like, it might seem funny, kind of not so much defining education, but even when I'm referring to education, I'm talking about that support for learning. So that's both formal within primary, secondary, and higher education, but also those other non-formal settings. So the workplace, training, self-study, apprenticeships, informal learning environments. I always find education is, you know, a controversial topic, no matter where you are, even at the side of a football field, in a restaurant, wherever. Everyone has an opinion on education because we've all been through it. And sometimes we can go down rabbit holes and have varying debates around education. But no matter what, I suppose fundamentally, we can agree that without education, there is no progress. And education and learning is that process by which individuals acquire, in which they practice and hone new knowledge through participating in socially mediated collective experiences, whether that's in a face-to-face environment or in a virtual environment. And technology adds a level of complexity to any pedagogical context. The impact of technology on our education system, you know, and within our classrooms, you know, adds that complexity, and there's no doubt about it. And I suppose the paradigm of having a teacher and a classroom, that's no longer status quo now. So, you know, we need to kind of, I suppose, it's keeping up with the technologies in many cases, isn't it, in terms of education? But we also have to exploit the advantages of technology, you know, the advantages that are offered by technology that we can incorporate into our learning environments that support the learning experiences and the interaction that our young people and students experience. In a paper by Chris Hoadley for the Spencer Foundation last year, they talked about 4 major developments in technology that impacted on learning and education. The rise of pervasive or total data, the platforms for retina grade experiences, so AR, VR experiences, deployment of AI and algorithms in the processing of big data, and also ubiquitous computing and the digital divide. And I'll touch on some of these in my talk. But firstly, I just want to kind of look at educational technology and just see how that's kind of how the trends are emerging or whatever. And yeah, as I said, education lies at a particular crossroads in society, because at the one hand, it has a responsibility for anticipating real life events, but education methodologies can't actually be formalized until after the practices have been defined. So, you know, and that dichotomy is aggravated when it comes to technology because of the fast pace at which it's constantly changing. But this infographic was developed in 2010, 2011, and an EU project. But I think it's really interesting to show how even back then, how they visualized and kind of predicted the trends in terms of ed tech, that firstly, in terms of the classroom in 2012, we're saying it's quite wide, but then it narrows as we progressed through the years. Studio environment remains the same. Virtual starts quite narrow, but then expands. But the trends in which they predicted were like around gamification of learning, opening of information, so open schools, etc., and provision of open access, digitized classrooms, so tablets, data projectors, etc., eye tracking devices. Disintermediation then was more around assessment algorithms and, so teacher assignment algorithms and telepresence. Then they were saying around mid 2020, we've tangible computing, so 3D printers, digital field trips rather than, and that probably came into being very much so last year with the pandemic and school closures. And then lastly, in 2030, looking in the virtual physical studio space, so very much the eye gear and VR experiences for students. But it's interesting just to see how those trends have kind of come to being, some of them we've really embraced and others are probably coming down the line. But for my talk today, I'm going to look at 4 different topics. So firstly, around pedagogical innovation and design for computing education, then talk a little bit about diversity in computing, AI and data, immersive technologies in education and what we're doing, and partnerships and collaborations. So very much just kind of giving an overview, but also then looking at some of the research projects that are ongoing in this space. So firstly, looking at pedagogical innovation and design. Educational technology doesn't just change educational practice, it's changing the educational sciences. And actually, I suppose maybe at the start I should have, when I say about learning sciences, we're talking about the cognitive sciences, psychology, design, computer science, instructional design. All of that makes up the discipline of learning sciences. And when we're any of the computer scientists here today or computer engineers, when we talk about systems development life cycle, we're, this kind of diagram often is displayed, I suppose, where we have systems planning and selection, then analysis, what it is we're going to do, the design, how we're going to do it, and then we implement, we code, and we operate and maintain. But the interesting thing is for educational design research, the pattern is fairly similar. This is a model by Susan McKenney and Tom Reeves, and they've analysis, design, evaluation, and then implementation and spread. And what they really propose and say is that, in each of these 4 different phases, educational designers require a really diverse set of skills and competencies in order to create and enable design within educational settings. And educational, research focuses conducting practice based inquiry to really get to understand and develop insight into specific settings, and in order to take further action and improve education and foster student learning. Susan McKenney talks about a zone of implementation, which is really that gap, I suppose, between what the technology can do and what the school or the teacher or the educational setting needs, and to construct and design in a realistic way that's going to benefit learning and teaching. And that word constructionism comes up time and time again in regards to computing education. Piaget, who some of you may have heard about, he talked about social interaction supporting learning, and that's very much fostered in computing education, isn't it? And students learn most when they're given the opportunity to explore and create knowledge that's of personal interest to them. Computers, technology help in the meaning making through construction, and really constructionism is so much the approach is particularly valuable to those young people or students who found, the traditional instruction-based setting kind of challenging. Constructionism allows students to build their knowledge, to construct their knowledge through design or implementation, and, you know, as a result of experiences and reflection. And, you know, lectures or textbooks only play a passive role in the learning in this regard. So Seymour Papert wrote the book MINDSTORMS, and he was a student of Papert, of Piaget, sorry, worked in MIT Media Lab, and then the Lego MINDSTORMS is maybe familiar to some people. Maybe you had to build it over Christmas or had to purchase it over Christmas. But so this book MINDSTORMS kind of, you know, was really cutting edge at the time in terms of, you know, enabling children to create and to design and to create. And, you know, we know in terms of learning computer programming and in terms of learning in general, I guess, isn't it? You know, it's in that emotionally rewarding state of being optimally challenged that we all are in a state of flow and where learning is richest and it motivates us to learn. If, for example, you know, if the student is insufficiently challenged, they'll learn nothing. You know, a signal of boredom will go to the brain and they'll give up. You know, they just feel that they're wasting their time. If the challenge is too high and the skill set is too low, anxiety then ensues. So, you know, and there is a relationship between anxiety and performance. And quite often, or sometimes when students are learning computer programming, they can't form that mental block, or, you know, or a mental block forms in their mind because they can't form a mental image of the problem that they're being asked to do. They can't relate to the abstract. They can't decompose tasks. So how do we alleviate some of these issues in terms of abstract conceptualization, for example? And really what we want to do, and what the learning sciences or you know, and pedagogical approaches in this regard, is really to put students in control of their learning, to try to take away some of the danger, to assist in the understanding and to help in terms of abstract conceptualization. You know, in terms of conceptual understanding, we want them, you know, to understand what ideas are key and which are going to be useful and which are going to be useful in what context, and to develop an understanding of why and what methods they need to use to embed cognitive skills, I guess, you know, too, and to really develop higher order thinking. And a lot of this is based on principles of cognitive learning theory. So our learning, it depends on what our learners already know, the pre-existing knowledge. Students and young people have to be active in understanding experiences, and they construct understanding, and that develops a change in the mental structure. Aligned with that is Lonergan's theory that could so this, I suppose, underpins a theoretical framework that can be adapted. So Bernard Lonergan was a theologian and philosopher, and I suppose, you know, what he proposed was that the process by which all adults come to know or learn is the same for all normal adults. And not only is it the same, but that we engage with it automatically. So we firstly experience, you know, he talks about it being common sense knowing. It's the experience we engage with, that we come and that we see and we engage in it automatically, I guess, you know. We then develop understanding, and we start to ask questions about the experience and to gain insight. And then lastly, we reflect. So we form critical knowing at this stage, and we form some judgment. So we question, is it so? So taking these three components, the goals that we want to alleviate any anxieties, I suppose, in regards to learning computer programming, underpinned by the principles of cognitive learning theory and Lonergan's theory, how can we take this into teaching computer programming? And what I did with colleagues in UL a long time ago now, it seems, with Sarah Moore and Eamon Murphy, we developed an intervention strategy to alleviate programming anxiety amongst undergraduate students learning computer science by taking Lonergan's common sense knowing, scientific knowing, critical knowing, using a physical object in terms of Lego MINDSTORMs, we then moved to scientific knowing and the developing insight and understanding by using a graphical object of Granada logo. I suppose nowadays one could use Scratch or some of the block programming would be more applicable. And then moving into critical knowing into the to the virtual object machine mental. So we call this existing representation of virtual mental. So really embracing the classroom code that the students were learning. So VB, Java, etc. So this had like a positive results and performance for students. It alleviated the anxiety. I suppose it helped with their conceptual understanding and developing the mental models for computing programming. But going back to this is my monkey, and just thinking, like, you know, the learning intention was to reflect on the learning sciences and computing education. So, you know, what has this got to do with learning sciences and computing education, or what's happening in this space now? And I suppose taking it, looking at computer science education policy over the last number of years, as early as 1981, the then Minister for Education suggested and recommended that computer studies should be introduced in schools. But it wasn't until 2017 that the Leaving Certificate specification was developed. And then in 2020, students sat the first Leaving Cert in computer science. So I was fortunate to be asked as one of the people to develop the specification. And really it is underpinned by constructivism and some of the theories that I've mentioned already. It has 3 strands, they're all intertwined. It's a spiral curriculum. So that idea of rote learning is not encouraged, and it was designed that wouldn't happen, that teamwork was going to be a central part of the specification and is a central part of the specification, that creativity is fostered. And really, the senior cycle computer science specification is really a very different specification than any other subjects at Leaving Cert level. And many of the, I suppose, senior cycle reform ideas that are coming down the line, computer science is leading in that way. Currently, computer science is offered to any school in the country if a teacher is, or a school has a teacher available to teach it, and it's certainly growing. It will take time, but it's growing. And then it also, therefore then has implications for us in the HEI sector too. And my second topic then is around diversity in computing and the inclusion and exclusion of computing and technology. Diversity is a fact of nature and of society, and I suppose at times it's sometimes ignored within the computing and software industry, but at the same time it's very much, I think it's very much in the consciousness of all now too. But we have to, I suppose, be mindful of it, and we need to be maybe more conscious of it, isn't it? You know, and I think also, you know, it's often students and young people that are well resourced or who have strong educational backgrounds are likely to benefit or embrace computing and digital education more. So being mindful of that fact. But a lot of policy has been kind of directed towards the provision of the hardware and of, you know, improving technology access to schools or homes. But sometimes that actually doesn't alleviate the underlying socioeconomic issue, and it's really just putting a plaster over the problem and isolating people even more. I think we also have to be mindful and conscious that in terms of diversity in computing, we're looking at many different aspects. Gender is one issue, socioeconomic, race, ethnicity, but it's also the intersectionality of all of these too. And that's, you know, we have to be mindful, and I suppose as educators, we need to spearhead a change of approach. And also being mindful that access doesn't necessarily guarantee participation. Even schools that are offering senior cycle computer science, the numbers aren't huge, like it's taken a while for it to grow. So that's something we just have to be mindful of. I think as researchers, we need to better theorize the links between the developments in technology, inequality, and education. And we need to strive to design technologies that facilitate a more equitable future. So back to my monkey and thinking, well, Cornelia, what are you doing about this? Or, what research is ongoing in this space? So NUI Galway, along with UL and Trinity, are involved on a Nessify discovery project called CodePlus that's aiming to engage with up to 10,000 young girls at TY level. And so we're running workshops for the young people. We're creating and organizing webinars so they meet people, female software engineers from industry. It's like the slogan, if you can't see it, you can't be it. And also, hopefully in the post-COVID era, we'll be able to take the young people on site visits to companies to really just, I suppose, open that door and ensure that they're aware of the industry and to the diverse set of skills and jobs and roles within the technology industry. Last week or the week before last, we presented another project that we're working on, supported by Google, that's looking and really just doing a review of the capacity for and access to and participation in computer science education in Ireland. It's based on the CAPE framework by Carl Fletcher and Jace Warner, to look at these three areas and just examine, I suppose, really the lie of the land in terms of computer science education in Ireland, and both the teacher education element, but also the student uptake and the system, how ready is our educational system for it. So that's just a project that we started last month. Another project that I'm involved in with colleagues from the School of Medicine here at NUI Galway, as well as colleagues from the School of Education at UL, was Spaceship Earth, which was a fun project with primary school children, where schools in Galway, Limerick and Kerry, we ran workshops and then gathered experiments from the children and sent high altitude air balloons up into space. We tracked them and then brought back the results to the children in schools. So really, I suppose, introducing STEM at a young age, but also making it exciting and inspiring young people to think about this area. But too, in terms of diversity, a long time ago when I was teaching software engineering, I used to run a module on computer mediated communication, or a project on computer mediated communication at a university in Germany, the University of Heilbronn, where our students in Ireland worked with students in Germany on software engineering projects. And though obviously now post-COVID, it's probably not as innovative, but remote teamwork was, that was something that our students had to embrace, or should embrace. And working with people from diverse backgrounds, from different locations is all very important. I continue the cross-institutional module, but in a different guise at the moment. I run a module on curriculum and assessment with student teachers with GMIT at the moment. And I think all of that diverse learning experience and interaction is it's important for our students. Bridging Worlds is another project that I'm involved in, and it's a collaboration with between NUI Galway School of Education, the ILAS, the Family and Child Research Centre, as well as with Foróige. And really, the Schooling at Bridging Worlds project really came about at the start of COVID, and when we really realized that there needed to be a wraparound model for young people, but particularly those in marginalized communities, where we needed to support both the young people, the teachers, and the youth workers in ensuring a shared focus and ensuring quality for the young people's education. So it was about kind of the parity of esteem between the youth worker and teacher, but also linking the formal and non-formal education space. It wasn't necessarily a technology project, but technology played a role in it. But it was really looking at how, you know, we ensured safe learning spaces for particularly marginalized young people. So my third topic is around data, AI, and immersive technologies and some of the implications for education. So we're all familiar, you know, that data is great, but it also can be harmful. I guess, you know, isn't it? You know, but AI, and you know, it's about being mindful of it, isn't it? You know, so AI is, yeah, as we said here, it will increasingly become the engine of education and student data the fuel. And it's about, you know, I suppose as educators, we have to pay close attention to the faith of some of the educational platforms that we're using, to the ecosystem of platforms that are out there that we as students and as teachers interact with. It's just being conscious of it. We need to consider what, where, how, you know, all of these systems are gathering our data, and what is influencing our learning. You know, where is the most significant, you know, or where is the most significant and influential learning happening in our society now? You know, what kinds of systems are undertaking the learning, and how's our learning intermingled with the ways that machines learn? Maybe some of you have read Shoshana Zukhov's book, The Age of Surveillance Capitalism, but she really talks about that division of learning and the division of labor, and raises questions about the distribution of knowledge and whether one is included or excluded from the opportunity to learn. And which people or institutions or processes have the authority to determine who is included and what they're able to learn and how they're able to act on that knowledge. You know, I think it just poses questions about our traditional formal learning, but it also highlights the extent to which we have to be cognizant and expand our horizons in many regards too. And that's not to say that, you know, there's lots of the technologies we need to embrace and have major advantages in this context as well. And so like in 2013, you know, this was an article about, you know, physics teacher at CERN, the European Organization for Nuclear Research, which is, you know, it was wonderful for his children, the young people in his class, or the children in his class, to be able to really see at firsthand what was going on by using Google Glass. We've gamified learning that's gamified learning that can be integrated and brought into the classrooms. That, you know, this is a game about division, learning long division. We have multi-user virtual environments if we want to play with U2, for example, and they're all exciting technologies that we can bring into the classroom and really provide students with thorough engagement. But going back to my monkey and thinking about learning sciences and computing education, you know, again, what am I doing in this space, and what's happening? So, and this is where the robot comes into play, I suppose. Yeah, so robotic usage can contribute to education, and we're certainly looking at that. And it can provide benefits as a teaching tool when matched with instructional goals. You know, the ability to do repetitive tasks, for example. There's flexibility with robots, presenting digital data, obviously, and just that interactive. So it facilitates learning, it motivates, it engages students and young people, and there typically is increased learning performance. And so I'm engaged in a project with the School of Medicine, the School of Psychology, around Dave, the droid audiovisual educator. And Dave is a semi-humanoid robot, and we have last year, the first kind of a project we did was in regards to hand hygiene, where we investigated if Dave was put at the front door of the hospital, how many people interacted with him and would listen to him in terms of hand hygiene. And there was an increase in hand hygiene behavior, which was positive. More recently, we did a diabetes education feasibility study. It was a public patient involvement where we had educational videos developed and an interactive quiz designed and delivered by Dave. So rather than a doctor having to teach a patient how to use and how to educate them in terms of some of their diabetes knowledge, Dave did it instead. And that study it was a small sample, but it showed that patients really liked Dave. There was increased knowledge, and they could see the benefit in engaging with Dave. So that was interesting. So it's certainly not replacing doctors by robots, or if we take Dave into the classroom, we're not replacing teachers by robots, but there is potentially a role that they can play in some elements of education. My last topic that I wanted to talk about, hopefully time's going okay, but is around partnerships and collaborations and who's creating the agenda. And I guess, yeah, it's, that commercial ecosystem in education, in educational technology, in computing education. I think, we have to pay close attention to that, to that ecosystem, to the global digital education agenda and who's dictating that. And perhaps, is there a need for regulation and oversight in terms of educational settings and companies or corporations supporting schools locally, nationally, or regionally? Digital learning environments, corporate players, that relationship is often, complex, and it's often guided by financial motives, marketization, and there's nothing new or nothing wrong with those relationships, but sometimes we do need to question in terms of regulation and oversight, I guess, because when one thinks about it, often in corporations, they're driven by financial convenience, efficiency, competition, but also, I suppose, in education, we have to be very mindful about humanity, sustainability, truth, justice. So it's thinking and asking those questions, but also, how can educators be supported in maintaining their unique role for the young people in their classroom, etc. And one way to do that, I suppose, is to really involve the teachers, and that's, I suppose, what we're trying to do in some of our projects. This is a project DEIMP. It was designing and evaluating innovative mobile pedagogies. The project just finished last year, but really we were encouraging and bringing teachers into the design of mobile pedagogies and transformative learning, involving school partnerships and really embracing mobile technologies in the classroom. Another project that I'm involved in is BRIST. It's around building a research infrastructure and encouraging the teacher researcher so that they are more empowered, I guess, really. And that BRIST actually aligns with an Irish project that we're involved in that's supported by the NCCA and the Teaching Council, again, to support the teacher researcher and to really encourage research in the classroom and that continuous professional development. So there are my topics for reflection. I hope I didn't whiz through them too fast, but what's steps forward, or what can we do? And it's fine highlighting some of the questions, but as educators, what can we do? I think we need to actively design technologies that facilitate an equitable future for all, and develop innovative research methods to align with this. We need to explore and to be very mindful of human learning and thriving, to develop high quality educators and leaders, to support the teachers in our field, both at primary, post-primary, higher education, And we really need to work to establish that value of formal education in an era of ubiquitous learning. We need to cultivate equitable educational spaces. And again, that equity is, you know, there's so many facets and variables to that. But we need to maintain a role in guiding and leading the global education agenda. Maybe leading it is very ambitious, but it's really, I think there are like 3 aims that we as educators kind of need to focus on, and that we can research on too. And my monkey again, but if we think back in Ireland in 1966, there was a paper on the investment in education, and it at the time declared, you know, free second level education to all. But part of the narrative of that was around investing in the future generations. So I think even now we have to think about that and investing in future generations. So what are the core values that are driving us within education and within computing education? What are the assumptions that we're making about learners and learning, and what models of pedagogy will that promote? You know, how technologies are influencing our education system is hugely important, but also we need to kind of be conscious of that. We want our young people leaving the education system to be engaged citizens, able to you know, contribute to democratic society in a productive and functional way. But we also need to research technologies that are causing harm at the pace at which they're being developed. And that's where the challenge lies, I guess, you know, isn't it? Because we're not as quick at researching as the technologies are emerging. So that's the challenge, to critically kind of examine, to question, to problem pose, and to problem solve. But I'm going to end on this slide by Neil Selwyn. I think if we talk in his paper, he was talking about what's next for ed tech, and he says about we need care rather than competition, cooperation rather than rivalry, and imagination rather than corporatized creativity. So on that note, I will say thank you.